School is moving on. We're now at April 6th. So, man, I mean, it's flying by. Seniors, you guys only got like, what, another 4 or 5 weeks left. So, seniors are very excited. We got seniors in this class. We got all grade levels in intro to programming. It's not just like a certain grade group. So, I know we have seniors in here that are getting excited about the year wrapping up. Not much left for seniors. Seniors get out a couple of weeks earlier than everybody else. For those of you who didn't know that, because they got their graduation happens before we're done with school, so they've got to get all their classes wrapped up. The senior finals are earlier than our finals, and all of that fun stuff. So that is coming up quickly. A little more to get caught up. I'll get that in a little bit. But anyways. So got a few cameras not on yet. And you guys are just getting the sleepy wiped out of your eyes. I've been up for like an hour and a half, and I'm still getting the sleepy wiped out of my eyes. So, the state science fair was Friday. My wife is the sponsor of that, so she was gone all day Friday. She got on the bus at 5 a.m. here at BHS and got off a bus at 11 o'clock at night on Friday. So she had a very, very long day on Friday at the science fair. But um, schools did well. BHS got the second overall school at the science fair, and West got the fourth overall school at the science fair. At the local fair, the regional fair that happened to U of A, Bentonville West was the number one overall school from our region. So both of our schools are being well represented at the science fairs around the state. And we have at least two projects going to go to the International Science Fair in Phoenix next month. So some of these students are doing really well with their science projects and get to go to Phoenix and compete against students from other countries. It's an international science and engineering fair. So that's a pretty cool thing. So my wife will be going to that as well. So she'll be gone. It's a whole week. You leave on Mother's Day and won't get back till Friday night. So that's a crazy one, but that's coming up. So, all right. What we got? 20 folks in here. Well, that includes me. So we're missing just a few, but we need to get started. So let's see. Let me get our lesson up here on the screen today. Intro to Computer Science. Let's go to our grade screen as usual. So remember, our grade screen will always show us where we're at. Looking at our grade screen, if we go down, we should be. Oh, I didn't get that turned in last week. I got to turn in my. I wrote the decoding ASCII program like 3 times last week, helping students with it, and I never turned mine in. I'll get mine turned in this week, due April 12th. 5.03 procedural and object oriented programming. So that's what we're looking at today. If you haven't got your decoding ASCII program turned in, it's not too late. Get it turned in. I saw several of you do have it turned in, and I haven't graded it yet for the most part. I think I've only graded a couple of them. I was busy with a lot of other things last week, and since it wasn't due till last night, I haven't graded it yet. So get that in 5.02. It's really easy. Remember, this one actually gives us all the code you need in the lesson. Most of them don't. They just teach us a few commands. This one has everything you need in the lesson on page 5, slides 3 and 4. You just got to figure out how to put them together, and you got to change a little bit of code. You got to put your own message. I'll post a video on that later, but I didn't want to do it right away because you should be able to do that one because they give you everything you need in the lesson. It tells you exactly how to do it. All right, let me put this back up here so we can look at this week's lesson. In fact, last week I had people turn in this program before the next class started last Monday because you can pull almost all of it from the lesson. It's amazing. All right, 5.03 procedural and object oriented programming, which we call OOP. OOP. Programming design approaches. So let's talk about how you design things, right? So let's talk about vehicles. Sedans, SUVs, trucks, campers. I mean, these are all vehicles, right? Because they've all got wheels, they got doors, brakes, hopefully, tailgates, air conditioning if you're lucky. Each of these pieces make up a vehicle. They have several vehicles over here for us to look at as they go through different color cycles. That's kind of cool. Some have different features, like different colors. Some have more specific uses, right? Some of these vehicles you buy because for a specific purpose. Like I wouldn't advise taking your smart car off-roading, but they're all considered vehicles. So vehicle manufacturers could create each one from scratch. All right, go get those wheels. Let's build this. Deciding the color, the size, and the engine type individually. Or they can create a template to mass produce them. All right, let's make 1,000 cars exactly the same and then send them all over the country. We can just tweak certain parts for a variety. For this, we'll put put some air conditioning in this one. We'll put electric electric windows on this one. We'll do a few of the hand crank. Just different things like fancier stereos, more plain stereos. But what about airplanes, rocket ships, and horse-drawn buggies? Horse-drawn buggies are technically vehicles too. So what do all these have in common? Well, they transport things. So they require a driver for the most part, although some don't anymore. They go to and fro. They go fro a lot. But remember how we're talking vehicles? Well, we're really talking about program design approaches. All right, I was fooling you there, just making you think it's vehicles. Program design is different. After completing this lesson, you'll be able to define procedural and object-oriented programming, compare procedural and object-oriented programming, and discuss the advantages of using object-oriented programming. So let's go to page 2. Procedural versus object-oriented programming. The term design approach refers to the way that the programmer thinks about his or her code. This choice of approach can vary by project or by programming language. Maybe use a different approach if you use a different language than Python. It can all kind of vary. There's 2 main design approaches when you're talking about writing a program. So first up is procedural. That's a programming design approach that divides well-defined tasks into modules or functions or procedures. Like we use functions in Python. We've done our main function, and sometimes we've created other functions to go with the main function. So when you're learning to program, you often start with a high-level description of what you're programmed to do, and then break it down step by step into the functions needed to complete your actions. So when you do this, you are writing programmer-defined functions. You take it one step at a time. First, decide what your function is going to do. Then what are you going to call your function? And then how's the function actually going to work? And as you go, you write the code needed to execute the program. So manufacturing vehicles from scratch would be like procedural programming. The other design is known as object-oriented programming, or OOP. So in OOP, the programmer thinks in terms of objects rather than functions. That's an instance of a class that encapsulates its own attributes and behaviors. And this is the first one we've really looked at a class in programming. Objects are defined using a class, which is the attributes and behaviors that describe a category of objects. And they're parts of a program that can carry out certain actions and interact with one another. Manufacturing vehicles from a template is similar to OOP. So let's look at some of the differences between these 2 ways of doing this. With procedural programming, description, it's an approach to programming that uses a list of functions or procedures and tells the computer what to do step by step, where OOP is an approach to programming that uses objects to carry out different actions. The application. Procedural is known as top-down design. We'll start at the beginning and we'll work through every step until we have a complete program. And that's a lot of what we have done this year in this class. OOP uses classes to define and create objects for a program. Programmers will write code and have objects interact to perform the actions. Languages, like early programming languages, including Fortran, COBOL, C, and BASIC, are mostly procedural. Most of today's newer language, like Python, we can really kind of do either one. We've done a lot of procedural type. It is object-oriented in many ways. Java and C++, these are object-oriented. See, when I was in high school, BASIC was the language we learned because when I was in high school, Python didn't exist yet. So we got to procedural. Examples: if you're planning a party the procedural way, you'd list all the steps that need to be done. Send invitations, buy food, decorate, make a playlist, prepare games. But if you were planning a party with OOP, the OOP way, you'd call it the Object Party Planner, and you'd do the same steps you did for your last party and just have it do everything you need. Put in the new party information and just let it automatically fill in. While procedural programming is a logical way to think about writing code, object-oriented programming is also pretty intuitive. Once you define a class, it's easier and faster to create new objects. But OOP does require more planning up front because more objects can mean more complex programs. So let's dig into some of the nitty gritty of the OOP way of doing this. Starting with the vocabulary. Most things you encounter daily are objects: cars, furniture, your phone, right? Objects. For each object, you can customize the way it looks. It has different features and different things it can do. And we define objects by their different attributes and behaviors. So these real life objects can be simulated with program code. So let's look at this image to learn about some important terminology related to OOP. All right, starting on the left, the constructor. This refers to the code that allows you to create a new object. It's a special method used when a new instance of a class is created. So the initial values of the attributes are set. So this is like adding a new contact in your phone. When you hit the new contact button, it has all these fields that pop up. We can put the name, the company, the phone number. You can add a photo, a second phone number, their email address, another email address, what ringtone you want to use. All of that is like a template when you hit new contact. The class, this refers to the template used to create the objects. So think of it as a blueprint that has existing characteristics you can use when creating new but similar objects. So each time a new contact is added to your phone, it's a contact class. In programming, we'd call it a class. An instance is the actual contact. Many instances of a class can be created. For example, an object is an instance of a class. Your one individual contact in your phone is the instance of a contact object. Like all your contacts, you use a class to create one. The class just sets up the template. And an instance of it is every individual use of that template. Initializing. This refers to what the constructor will do when you use it to create a new object. It will initialize the object in the program. When you create a new contact, all the attributes will have initial values, right? Like the name will probably be blank, but it may have just like some X's there to show you'll put the name, but it'll just set all the defaults. Most of the defaults will be empty in a new contact. It'll have empty defaults. Although your ringtone may already be set as the default of whatever your phone default is. So there may be some things that are already set. Let's look here where it has the phone number. Attributes. This refers to the features of the object. Like, what is this object's phone number? The attributes of a contact might include a phone number, email address, or a picture. Attributes are often nouns and adjectives that define the properties or the characteristics of an object. And then if we go down to the bottom here, the behaviors. This is known as methods. This is referred to the actions that an object performs. Like when this contact calls, this is the ringtone, the behavior that your phone will take. You can set specific ringtones or vibration patterns to a specific contact so that when that person calls, that specific behavior is performed. Like when my wife calls, my phone has a different ringtone. It plays a different song. So without even looking at the phone, I know it's her on there because I've set a different ringtone. Oh, we have a programming spotlight. Mark Zuckerberg, born in 84, least likely to succeed. That's funny. Dropping out of college his sophomore year at age 19, it would seem like he would be the most not likely to succeed college dropout. But we know that's not true. The Facebook co-founder began programming at age 12, and he was a billionaire by the time he was 23 because he created Facebook while he was in college. The Facebook interfaces make full use of object-oriented programming, using classes to make new objects. When you create a new Facebook account, it's a class, and it has this whole template that you fill in information. User profiles, your React buttons, the notification features, those are all part of the class that automatically feeds into the Facebook profiles. Page 4, what are the advantages of OOP? Object-oriented programming has a lot of advantages. There's a reason it's the way that most programming has evolved today. Let's check out some of the benefits. For one thing, reusable code. Once programmers write a useful class for one programming object, they can often reuse that class in another program instead of starting from scratch. Example, if you create a class for a deck of cards, you could reuse that in any program that you're writing that needs a deck of cards. Like if you're building a solitaire program and you build a class as a deck of cards, and then you create a Grow Fish program, you've already got a class created, so you don't have to redo that. It's reusable because the way you create a deck of cards would be the same every time. Inherited traits. Programmers can create new objects that inherit traits from existing classes. That means they can add new features to an object without having to start from scratch. Save a lot of time and effort. For example, if you create a vehicle class that has all the basic functionality of a vehicle, it moves, it carries people or things, it starts, it stops, you can build onto that to create more specific vehicles. Like this one's going to be a convertible, this one's going to be a bicycle, this could be a semi-truck. But you have the basic thoughts already. Flexibility. Programs created using OOP are easier to develop because of their flexibility. Objects can be used in a variety of ways and have different behaviors for different purposes, depending on the program. So, for example, if you create a class for your bank account, many bits of information, the name, social security, your birth date, are needed to open the account, or if you're getting a loan. But for simple transactions like making a deposit, you only need basic information like your name and account number. The bank account class can work for all of this. It can store all that information and just use what's needed. Easy to maintain. Object-oriented programs are written modularly in objects. Here's this object does this does this does this. It makes it easier to maintain and understand once it's developed. For example, if you're planning a meal and you burn the cupcakes, you only have to fix the cupcakes. You don't have to start and build the whole meal again. All right, I've already got the appetizer, I've got the entree. I just have to redo the dessert. So in OOP, objects can be maintained separately, making finding and fixing problems much easier, right? If there's a problem with this part of the program, I just have to go look at that object part. I don't have to go through the whole program because it's built in different modules. All right. Wow, this was an interesting week. There was absolutely no code in our lesson this week. Let's look at the assignment. Assignment is just a 5-question quiz over procedural and object-oriented program. There's true, false, and 4 multiple choice, all based on very, very short lesson this week because we didn't have to go through any code. Our program next week, and I haven't really decided exactly what it's going to be like, but we have a program next week that's a superhero program where you create a class for the superhero as a separate module to where you could create any superhero with this class. And then in your main part of the program, you create superheroes. You can create 1 or 2 or 3 or 4, all using the same superhero class. So it's a fun program, but it could be a lot to it. I haven't decided. Some of it I'm going to give you the code, so you don't have to write the whole thing. Some of it you'll need to create your superheroes, and you'll need to create a story for your superhero. Figuring out exactly how much of the program I'm going to give you to start, because I am giving you a start on that because there's a lot to that one. But anyway, Simple week this week. This is a good week to get caught up if you're behind on anything, because all you have is just a little 5 questions. Very short lesson this week. It only took us 20 minutes to go through it. So I will give you the rest of this class period. You can get this done. If you haven't had breakfast, you probably got time before your next class period. And I'll let you have that. And if you're behind, get with me. If you got questions, hang around. Even if it's about last week's program, I'm happy to help. So have a great week, guys. I'll give you the rest of this time for yourself.